Hey guys, thanks for joining this tutorial, and this time we'll be looking into some components that allow you to subdivide wires into multiple points. And I prepared this script just with two wires, right? We have this gray wire and this white wire on the top. They share the same length, and we subdivide them in multiple points by using various kinds of components. So we'll be using these components for the subdivisions. Those are the most important in this tutorial. And here we have some environmental components that set up the background color, draw the grid, adjust the camera. And here we have components that create the wires themselves, right? So we have here the JSON editor with 4 coordinates in it that go to this component that creates polygon wire. And then we round up that polygon with this fillet 3D wire component. And if you want to check the polygon itself, this is how it looks like. It has these sharp corners, right? And we just round them up by using this fillet 3D wire component. So let's hide the polygon now. And we can change the radius here, like we can say that we want to round to 7 or 5 or 4, and everything adapts, right? Because it's all parametric. So this component then is translated with this vector XYZ upwards, and the white wire is being created. And both of these wires, the translated one and the filleted wire, right, are fed into these components that subdivide them. And then we create those points here and lines, and then we visualize everything. So this allows you to better read the subdivisions, right? Now, for example, you see that the linear edges have more sparse subdivisions, whereas the rounded edges have more dense subdivisions. And that is caused by this component that we're using. It's called points by params. And that just creates parametric subdivision of your wire. And parametric space is not exactly the same as sort of geometric space, right? So the divisions are not really based on the length between the points. And yeah, let's just, look into another component, how that compares to the points by params. So let's now divide the wire by using this component, and let's plug it to the Sparse component. In this case, you'll see that the distance between all the points is exactly the same. This is, usually what you actually want when subdividing wires, but who knows? Maybe you have a situation where you do want, for example, to have more points of subdivision in more dense parametric space. So then you use this component, right? So here in both of these components, we can change how many points we want. So for example, I can say that I want 50, for example, and then I have this kind of model. And if I change it to 400, it will be really dense, and they all are looking quite great. So now let's look into this component, points at equal length. And it's quite similar to this one, but not exactly, right? Because this component just takes the full length of the wire and subdivides it into 400 pieces. Whereas this component, we say that the divisions between each point have to be 1 unit, right? And this will be giving you the result that goes around the wire like this, all spaced by 1, but then at the end you will always get, probably always get this sort of gap that doesn't meet the criteria. And that is because the wire length is a bit longer than a healthy number, right? So we say that steps should be 1. We see here in this component, we measure the length of the wire, and it's 86. So you never, will reach that in the step of 1. And that's why we see this in the result here. But we know that component generates points which are spaced at equal distance. And that is also sometimes very useful, right? Okay, so let's look into another component. We have here points at patterns of length. This one's really fun because you see what happens. We create a sort of pattern of lengths that is repeated across those wires. So here we have the pattern itself in this JSON editor. It's just a list of 5 numbers now. So we start with 0.5, 1, 0.2, 2, and we can find that pattern here like this. So if I zoom in and let's start and read it like this. So Here we have 0.5. I would imagine it's this one. Then we have 1. It's a bigger gap, right? Then 0.2. Then 2 is a big gap, a really big one. And 0.1, really small gap, right? So, and then the pattern repeats. Again, 0.5, 1, etc., etc. And so it goes around this wire, right? And at the end, of course, you will also get, as with the previous components, some sort of remainder that might not be in the list. And you have here some options, of course, to include first and last points, to also try to get the next one. But yeah, these are less important. So let's look into this component. The last one is points at lengths. And what I did here is a bit different. I've just generated 100 random numbers. And I said that the maximum number has to be the same as the length of the whole wire, right? And that produced this list that you can inspect here. These numbers are all random. And we feed those numbers into this component. And what happens is that this will generate a quite cool looking result. So you see that the randomization really works. It's quite sporadic, but yeah, it did provide us with all those subdivisions wherever we asked them to happen. So it's 100 subdivisions, but then randomly placed across the wire. So we went through all of these components that I wanted to discuss. This is it for this one. Thanks for joining this video, and let's see each other in the next one. Cheers.